Hello, everyone. So we have two questions for MATHCOUNTS. So we have like number 7 and 8 on a state target run. So you do expect to get like these questions like about 3 minutes. So the first question is geometry. So let's get started with this one. And we are given ABC, the right triangle, which is given right here is 5, 12, 13, which is good to start because that's a triple. Okay. And the squares are drawn on each side. Segments DE, FG, and HI is given as vertex of the square is given. What is the area of the hexagon? D, E, F, G, H, I, basically whole figure, right? So we can kind of find the area of the ABC, which is not too challenging, which is a right triangle, right? So 5 times 12 over 2, which is 30. So we do have this one. And this is square, that's 13 on each side. So this is also 13. So you will get 169. And the same idea right here, 144. And this is the same as identical because FB is also 5 and BC is also 12. So that means this area is also 30. So we got that. So everything is except the like EAD and ICH is actually found already, right? But how do we deal with this one? So we have AE is like 5, right? And you may find the area of this region as well. But here's what we can try. Like we do need to find the area of the triangle. But if you want to find the area of triangle, without really using any like advanced tools, we should be able to use the basics of the area approach, which is like base times height over 2. But if I take this as my base, or if I take 13 as base, I need to have a height, which we don't have it based on what we are given. So maybe we can extend this AE in a way that we are going to able to make a drawing to find the height. So if I drop the D to like extension of AE as my height of the side 5, so that might be useful. So I'm going to call this as H, okay? So if I find this somehow, then I'm going to able to get the area of this triangle, okay? Because that will be my base and this will be height. But maybe we should extend this a bit because I do need to know this as well. So this side is 12 and this side is 13. So I just need to find a height for those as well. If I extend the like CH this way, maybe that might help, or I can just continue doing this, but let me extend this one and then take the 12 as a side, right, as a base. So if I have this, it doesn't look like we have a lot here, but let's try and see if we can get something. This is a right triangle, and this leg is 13, right? And then the hypotenuse of this triangle is 13. And let's see what else we can. Maybe I should extend this a bit until we hit that line, because I need to get somehow the altitude of the triangle that we are trying to find area for. And if I do have some sort of like congruent figures or similar, that might be useful. How do I know that I need to search for? Because I do have some 90s, so there are triangles that is always like complementary. So if I name this is like alpha, so the alpha 90 and this guy, I'm going to call this is beta. The angle alpha and beta is add up to 90 degrees. Okay, so at the same time, angle D, like in this square as a whole, angle A is also 90 degrees. But one part is beta, which means the other part should be alpha, so we can get this sum to be 90. And since we extend the straight line and straight line, and this is going to be a 90 degrees as well, because this was a vertical line and this was a horizontal line, so which is why that has to be perpendicular. And now the hypotenuse is 13, and this hypotenuse is also 13. So this triangle and this triangle right here are congruent because they have the same hypotenuse and their angles are equal. So this is also beta. So meaning that we can say this is going to be like this piece will be 5, and this piece will be 12 because that was this side BC and the same as this one. If this is 12, D to this point is also 12. So I hope that was clear. So if you didn't like it, so you can draw the triangle outside maybe, so you can get some reasoning. But again, we were able to figure that, like if I call this is H, D, A, H, this triangle, and A, this corner, and C, these triangle are congruent as well as this one. So because of angle congruency. And so for that reason, we can say this is 5, and then this is 12, which is the same as these two. And that means this height is also 12. So now we may find the area of this triangle. So if I take 5 as my base, then 12 will be height. So 5 times 12 over 2, which is also a 30, right? So that means this region right here is also 30. So the only thing that I need to find is this area. Maybe I can like drop the altitude for this space by taking something from this to this. If I drop the altitude, I do have now, like we said this is alpha, this is beta, the angle at this C is 90. So that means this part is going to be alpha and this part will be beta, which means this triangle right here and this one is right here are also congruent because their hypotenuse is 13. So that means this is 5, and then this leg is 12. So if this was 5, so that means this is 7, which we don't need it. You can extend this just to see there will be a nice like square in the middle. So now if you want to find the area of this triangle, so the height is 5, the base is 12, so 5 times 12 over 2, which is also 30. So we have like 1, 2, 3, 4 of these 30s, which is 120. And then we have 125, 144, and 169. So if you add 25 and 144, because this is 25 as area, that's 169 when you add 25 by this. And then you have another one right here. So this largest square, you have to double this. If you multiply this by 2, you get 8 and 16, 13. That will be 338. So if you add this to this, so you will get 5, 4. So 458. So I hope I didn't miss anything, but that looks like our answer. So this is one way we can approach this problem. And second way, like the most challenging part of this problem was finding the area of the triangle on this side, right? And there are some approaches, but here's another reminder I like to make at this point. So as soon as we know this is like 5, this is 13, like this is 5, this is 13. So you really need to find the area of this triangle. And we just got the answer by using some basics of geometry, but we can use some sort of trick as well. So whenever you are looking for the area of a triangle, we can multiply 1/2 by any two sides, which is a times b, and sine value of the angle in between those two sides. For example, if I take this is 13 and this was 12, so the angle in between, if I name this is like alpha, okay, this angle right here, which is alpha, the area of this triangle will be 12 times 13 times sine alpha over 2. But in order for us to do so, we do need to know the angle measure, which we don't, or we do need to know the sine value of this angle. So if I do see this is a 90 degrees, and then this is also 90, which means the alpha and the angle right here, I'll say that's beta. Those two angles are supplementary because we have two 90s and other two angles should add up to 180 as well. So if you know that we do have a relation for the supplementary angles, if you have two angles that are supplementary, then sine value of one angle is the same as sine value of the other angle. So which is why I will say sine alpha equals the sine beta. If you don't know about this, that's one of the basics of the trick, but you can just skip for now, but it's good to know even with these questions, because if I do know the sine beta, then I know actually sine alpha as well, because I know the sine beta is equal to 5 over 13, because that's opposite, this is hypotenuse. So that means this is also sine alpha, so 5 over 13. So if I plug it into this equation, so you will get 1/2 times 12 times 13 times 5 over 13. So these will cancel. So you get 12 times 5 over 2, which is also 30. So you see that this was the answer that we got for this area, and the same story goes on this side as well. So you get that the same result. So this is something I like to show because even though this is like a counts problem, so they don't really require the trick, but some of the basics of the trick is really useful. So that might be sometimes easier than some other geometry background using. So that's why I like to remind this as well. So let's look at the next problem. Here's the number 8. So we have M-shaped curve is created by graphing the parabola y equals x squared in the coordinate plane, and then reflecting the part of the parabola that is about the y equals 1 across the y equals 1. Okay, and then there's a horizontal line that intersects the M-shaped curve at 4 different points. AB, ABC, and CD will be equal, and based on this, what we want is the AB. So like, let's make sure understand the question. So like, we were given the parabola, like the original figure was like this. Okay, so you were extending this in all direction, like the positive direction. And what we did was we take y equals 1, and we flip this, we reflect this over this line. When you reflect this red portion, you will get this bottom portion. If you reflect this over this y equals 1, you get this part. That's basically how we got this figure that we are given. Okay, so now based on this, like we know the given parabola was y equals x squared, which is the original one right here. So the y equals x squared. And if you reflect it, so you're going to see the distance between the y equals 1 and origin was just a unit. So if you want to kind of extend this, you are going to hit that point too. So you will get something like this. You don't really need to do this, but it's just easier for us to get maybe equation of this new parabola. So when you reflect something over like horizontal line, it could be x-axis or y equals something. So you're going to make the sign negative. So you're going to get y equals negative x squared. But the problem with this is equal to this graph. If you had this graph, so instead of doing this, we were going to get just the on the other direction. This is the case for this graph. But this is not touching the origin, right? So this is just 2 units above the origin, which is why our graph will be +2. So again, now this is the graph of this guy basically. Okay, so that was something. And why this is important, because I like to know the equation of that new like curve so I can get something out of it. So the question was also telling there is a line that is going to be like given as a horizontal line. There's a horizontal line that will intersect that M shape 4 different points. So when you do so, let's assume it's something like this. It doesn't have to be right there exactly, but I'm just going to make it visual figure. So and then let's say this is A and this is B, that's C, and this is D. So we are told AB, which is this distance, and B to C and C to D are equal, which means my line should be lower than 0.5 most probably, because otherwise BC looks like too big compared to AB, but it doesn't matter for now because I like to get some algebraic expression to so forth. So since this is a parabola, it has to be symmetric over this y equals like x equals 0. So if I name this is x, since that point goes through y equals x squared, the y value of this C, so I'm going to say C, is going to be x comma x squared. So meaning that your y coordinate at this point is y coordinate is x squared. So that means every y value on this line is the same as this one, so which is something we now know it. So since this is x unit, then from this line to this B is also x unit. So if I want to kind of say this is x unit, that will be x unit as well. And then BC is 2x, and then CD should be 2x as well, and AB has to be 2x as well. So what does that tell us? So if I move like from this x 2 units to the right, so I should be hitting that point D, which is going to be 3x comma y value. Y value is still x squared. So that's the point D. And if I want to find the A similarly, I need to go from point B. Point B was like negative x in terms of its coordinate, then if you go 2 more units to the left, you will get negative 3x, and the y value is still x squared. Why this is the case? Because any point on this line should have the same y value, which is x squared, and we do have this negative because we are just moving on the left direction. So now we do have a coordinate of a, b, c, or d. We can plug any of these points into this equation because this graph was the equation. Like if I just do remember, this is equal to negative x squared plus 2, right? And if I just plug this point into this equation, I should be able to get my x value. Let's do that. So the x squared is your y value. So the y squared equals negative of x squared, which is negative 3x to the second power, and plus 2. And if you, but this is x squared, right? Because the y value is x squared, and this is the equation I need to solve for. If you square this one, you get 9x squared, but there is a minus, so that will be minus 9x squared. If you add both sides, 9x squared, so you will get 10x squared equals 2, and the x squared will be 1/5, and the x, if you take the square root, will be 1/5. So, but the question was asking the AB. AB is just the twice of this distance, which is 2/5, and if you simplify, you will get 2/5/5, and that is my final answer. I'll leave some additional resource in the description. You can take a look at if you couldn't really get these two questions less than 3 minutes, so which means you need a bit more practice. Okay, I'll see you in the next video.